Okay, everyone, it's Mr. Rops here, and we are going to work on our first puzzle with quadratics. And here is our equation, f of x equals negative x squared. And so if we think about our building blocks and such, I know standard form looks like y equals ax squared plus bx plus c. And so when I have it here, I can see that this is my a value is negative 1. There is no, it's like plus 0x plus 0. So my b value is 0 and my c value is 0. And it is in standard form. There is no other form here as of yet. So I can clear this off. Okay. Next thing what I want to do is I want to graph it. Well, if I want to graph it, what you've learned in the past, when I make my xy axis, I know that my standard parabola is this one here. This is my parent function. The negative means it opens downward. Okay, and so it's not this one, but it's going to open downwards. And I'll show you why in just a second. So here is negative, so it opens downwards. You can see on Desmos there. And so my graph is going to be as such. It's going to be like this and as this. And when I make my table, I know I have x, I have negative 3, negative 2, negative 1, 0, 1, 2, 3. And this is f of x. Well, negative 3 squared is 9 times the negative, which will be negative 9. That's why I go over negative 3, down negative 9. Negative 2 squared, well, this is 4, and so it ends up being negative 4. Negative 1 squared is 1. Negative it is negative 1. That's 0. This is going to end up being over 1, down 1, because it's negative 1 squared, which is negative 1, negative 4, and negative 9. If you're not sure about these calculations, please try them yourself by plugging them into here. Okay? And so then I also then get f at negative 10. Well, if I'm going to do f at negative 10, this, remember, is the x value. So it's negative, for my function negative 10 squared. Well, that's 100 times a negative makes it negative 100. So f at negative 10 is negative 100. And so moving to our key features then, well, our key features, we can see that m, our slope, there is no slope. It's irrelevant for quadratics. I want my a value, it opens up. My a value is 1, so I'm going to mention the a value. A value equals 1. Also going to mention the vertex axis of symmetry. My vertex, well, here's my maximum, it's 0, 0. My axis of symmetry, well, that's going to be right here still. This is my line, is symmetric about this, which is the line x equal to 0. I also need to talk my x and y intercept. Well, that's easy in this case. My x intercept is 0, 0. My y intercept is also 0, 0. And then the last part's domain and range. Well, if I look at domain, thinking about all my vertical lines that I can have here, and I'll use a blue line here, right? I think about where will this blue line touch the graph? Well, touch, yes, yes, yes. Even here, eventually it would touch it. So everywhere I put this line, eventually it will touch the graph somewhere. And so because of that fact, x can be any real number. When I look at the range is talking about my y values, and I'm going to make horizontal lines for this one. Make a horizontal line. And here I think about where does it touch the graph? Well, it touch, even here it touches the graph. Everywhere touch, yes, yes, yes. Touch, yes, 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 yes. Touched, yes, 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 yes. No, 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 no. So here's where it changes. It changes at 0. So I know that at 0 it changes. If y is less than or equal to 0, that's where it will touch the graph. And so that tells me all these things down here. Okay, let's keep on going here. So now, place a check mark vocabulary and notation here. So place a check mark next to the appropriate vocabulary to describe the transformation of the parent function. Well, what this has done, that negative x squared means it's upside down, which means it's been reflected over the x-axis. It has done this. The vertical stretch by factor of 1 means there is no vertical stretch. And I'm not going to check it. There's no shift, and there's no shift up or down, left or right. We're going to see those shortly. So this is the only thing that happens is the reflection of the x-axis. That's because there is a negative here. And then finally, we're going to do the problem solving algebraic fluency. Given g of x is x, I want to solve negative x squared, which is f, equals to x. In order to solve that, I'm going to bring everything to one side of the equation. I'm going to subtract the x, which equals 0. And then solving this, I'm going to factor out a negative x, which leaves me with x plus 1. And then, well, this could be 0. Negative x could be 0. So x is 0. Or x plus 1 equals 0. So x equals negative 1. All right, so here are my two solutions algebraically. If I'm going to graph it, well, I know that this is negative x squared. The line y equals x, well, is this one here, which is a 45 degree. So here is x equal to 0. Here is x equal to 1. And if I check this on Desmos here, y equals x, I can clearly see that I mislabeled this as 1. It should be negative 1. Okay, and so this takes us through our first puzzle.